There we go. All right. So, well, welcome everybody. Thank you for joining us. And as Mahmoud said, I'm very avid open source believer. I work on many open source projects, and on all the things that you're going to see today are open source. And for whoever is joining us at OracleCon next week, as Mahmoud said, we have this event called Hackathon, where we basically work together on open source projects, neck to neck, side to side, with project leads and everybody else that's interested. And at the end of the session, which may be a couple hours or could be a whole day, it's up to you, we contribute back to the open source project. So we make a contribution, we package it, whether it's a Git commit or blog post or something that makes good for the community. Okay, so many of the things that we're going to see today are based on my own personal experience and working with customers and open source projects. And this is how I figure out a few libraries that if you put them together, if you combine them in certain ways, then you can get better results. Now, I'm going to, well, if I could see you. Yes, so most of you are Java developers. I suppose that most of you have worked on the server side, whether this is Java EE or something else, and that you have to have some sort of experience working with HTML or REST APIs. So because what I'm going to propose to you today is to, let's say, if you had the task to build an application that had to consume a REST API, and I mentioned REST API because, again, most of us have so far have to be already used to working with the REST API, whether it's consuming or producing. And this application is chose to that has to be a desktop application because it's one of the things that I like. But if you are producing a REST API, you pretty much don't care what kind of client you have at the other side. You simply put up the contract. The components should be small and reusable. We should say no to boilerplate code, so no verbosity, try to reduce it as much as possible. And of course, all the behavior that we have should be easy to test. Now, without any further ado, these will be the libraries that I'm going to cover today. On one side, I have put the production, on the other ones, the ones for testing. Now, let's see some hands in this. How many people are already using Java 8? You see, we were using a lot of Java 8, then I certainly would like to talk about JUnit 5, but I think this is still yet in the early adoption stages. One more thing, given that we have a global microphone in the room, whenever you have a doubt, whenever you have a question, please raise it, and I will start immediately and try to answer as soon as possible. Because there are no silly questions. What is there actually is something that I didn't explain very well, and you have a doubt, so I will try to dispel them as soon as I can and as best as I can. All right? Everybody's okay with that?
Yes. Yes.
Perfect. Great. Okay, so here we go. As said, everything that we're going to see today is open source, so you can use it directly on production. You can use it on your own projects. As long as you follow the licensing terms. Most of the libraries licensed on their Apache version 2, which is very, very friendly in terms of commercial endeavors. So everything should be fine. My goal is at the end of the session, you feel a little bit like this, energized and encouraged to test out some of these libraries and give it a shot with your projects. Hopefully, I will get at least one of you. All right. Mahmoud already introduced myself, so this is just basically me saying, hey, I'm from Mexico. I live in Switzerland. I love open source. I love to work with many different projects. I've been involved with many different projects along this on all these years. I work with Eclipse, with Apache, with the JCP, so many different things. Anyway, okay, so this is the application that I want to show, and this is the application that I want to build. All right. So in order to do this, we have to know what REST API we're going to use, and this, in the case, is the real GitHub API version number 3. You can get it from that particular URL. The only operation that we're going to center us right now is how we can query repositories. So if you navigate to that URL and you find how to, what is the entry for the repositories, we find this particular URL now that tells us how we can list Basically, what we want to do is issue a get HTTP call with that particular path, with the organization as a placeholder for the name. In the case that you saw just now was Griffon Legacy. So once we get this, once we issue a get call like this one, we will get a JSON payload back. This element that we see here is actually a list of JSON objects, and they actually have, each repository has more than 40 properties, and we only care a few of those. For example, the ID or the full name, the name, and the HTML URL. These are the things that we're going to display in our little application. All right. So what we're going to need in order to build this application, and again, many of the libraries that you're going to see today can be applied on the desktop, on the server side, on even on mobile. So the idea is to showcase some use case, and then you might think of a different way to put this together in your particular project. So in the time and date now, which is 2018, almost the end of it, I will say it will be very hard for someone to build an application without some sort of dependency injection, especially a mid-size to big-size application. We need some way to talk to a background server or using HTTP and understand the REST behavior. We definitely need to do some JSON mapping, because what we get from the server is JSON, and we work with Java classes. We need a way to reduce the verbosity, to not write boilerplate code. And because we are talking about a Java effects application, we have to handle concurrency. Because it doesn't matter what UI toolkit you use in the Java space, you have to take care of a single very important rule. Everything that is UI must happen inside a specific thread, the UI thread. Everything that is not, such as computing a value, talking to the database, accessing the file, the disk, or issuing a network call, which is our case, should happen in a background thread. Okay. So you can get the code for the application that we saw from this URL. There are actually 6 different variations of this application, because we have different options for the libraries, and we can have pagination or not pagination. So every one of them will explain you what is different, and all of them have full tests. So yeah, you can play around with this, and again, it's full open source. So let's start with dependency injection. Basically, what we want to do is define a contract. In this case, we have a component of type GitHub that defines a method and returns a value of type promise. And we want to implement, what we want to do is implement this particular interface and have it be used as a collaborator on some other components. One thing that you will see in the code, once you have the possibility to browse it, is that the JavaFX application is designed using the MVC pattern model view controller. So what we want is for the controller component to have access to this GitHub API so that we can query the network using REST. So for example, we can do this in this way. Say that you have the controller component, and you can inject a few things, few collaborators, such as the model and the GitHub contract that we saw earlier, and then just go to town with it. In this case, this is method called load repositories that at some point you can see here on the second line of the method, that it issues a method call for the repositories, passes on arguments, and then performs some operations on the result. The important thing is that we do injection. So I expect most of you to be already familiar. But in case that you haven't seen this before, Google Juice is the reference implementation of JSR 330. This is the standard that defines how dependency injection should be done in the Java SE platform. If you're using Java EE, you might have encountered CDI, which is the standard of how to do dependency injection in the enterprise edition, the enterprise platform. So Juice is quite tiny. It's quite small. It gives you just the most basic things for doing dependency injection. What we're seeing here is 3 out of 5 different ways to do bindings. The first one, we can bind interface, which is the contract that we define it, to a concrete class. and put in a scope. The scope in this case is singleton, which ensures that it's only one instance that is managed by the container for this particular type. You could have different scopes. You could have, for example, prototype, which will create an instance, a new one, every single time you query for it. You could have conversation scope or application or session or you name it. You can even create your own custom scopes. The second binding, both the source type and the target type are exactly the same. And we are binding them also into this singleton scope. And the third one, it might look a little bit funky, but this is how you provide lazy values. So what you're saying with this particular binding is that you want something that implements the GitHub API interface, but you do not create the object yet until you actually need it. So that's why we defer to using a provider. Now, the advantages of using Juice is because it's the reference implementation. You can bind any type, any instance, any interface, abstract and concrete classes, even custom values. You can provide lazily evaluated instances using providers, and it has an extensible life cycle. As I said, this particular library doesn't give you much beyond dependency injection. If you're used to Java EE or Spring, you might have seen that you can annotate methods with post-construct and pre-destroy, which gives you additional lifecycle for that particular bean or object. Juice doesn't have this, but because the lifecycle provided by Juice is extensible, there is an additional library out there, an extension to Juice that gives you this capability. And this is one of the things that you will see inside the source code once you navigate to the repository I posted earlier. As a bonus, if you happen to use Juice, you have access to Guava, Google Guava. This library was created, I think it was a little more than 12 years ago. And it was created because there were some missing types and some missing information coming from the standard Java library. For example, if you ever had the need to know to which key a value is mapped, given that you have the reference to the value, you make use of something called bimap. If you ever had the need to have multiple values associated with one specific key, we usually do this by hand, by associating the value with a list or a set and doing the handling automatically, manually for this collection, where the multimap automatically handles the collection that we give it. If you had the need to have two keys associated with a particular value, then you would use the table collection. There are additional methods and utility classes for handling collections and strings and reflection and I/O. And it gave us also functional programming in the sense of predicates and functions. But it works since JDK 6. It has nothing to do with Java 8 or Lambdas or the functional interfaces that we got in Java 8. So I would say that the functional programming support that is provided by Guava is no longer needed if you have already jumped into Java 8 or even later versions of Java. If you're not using Juice, probably you are already using a Spring. And here I want to just mention Spring Core. There are so many different projects in the Spring portfolio, but Spring Core is the original one. This will give you dependency injection, which is compatible with JSR 330. You can define it using XML, like in the old days, or you can use annotation approach, or you can use a programmatic approach. It's up to you. But there are many other things that you get for free if you happen to use this as dependency injection. For example, there are tons and tons of assertions, serialization, the JDBC template, creating clients and servers for JMX is so easy with a Spring Core. It should not be allowed. It's really, really so easy. And one more thing, I don't know if you remember, but pretty much every implementation of the message format interface coming from the standard Java library is not thread safe. This is the reason why we have said in the past that simple date format, usages of an instance of simple date format should be confined to either be a singleton or you don't share it with any method in any way because this particular instance is not thread safe. But the Spring gives you thread safe versions of all these formats and then some more. So if you're dealing with internationalization and you're already using a Spring, you definitely want to have a look at the message source and all the message formats that a Spring provides. So the next step is we're going to reduce boilerplate code. And here I'm going to ask you, how many of you know what are the conventions, what kind of the code that we have to follow in order to, that I have to write in order to follow the Java Beans convention? If we want to have a well-behaved plain Java object, what do we have to do? For every property, we need a getter and a setter. If it's a immutable property, then it has to be defined as final. The type has to be immutable. We can have to define in the constructor. We don't define a setter for it. This is a well-behaved POJO also requires you to provide an implementation on equals and hash code that is suitable. Optionally, but it's good to have, you can have a toString method. So you see the rules are simple, yet the amount of code that you have to write, it's a lot. And I know that you can use your IDE to generate these things using macros. It doesn't matter which IDE, pretty much all of them provide some kind of macro template generation feature. The problem that I see here is that once you have generated code using a machine template, the IDE macros, you are now in charge of maintaining saved code. So your IDE could help you rename a property, and hash code to a string and equals will react to these changes. That's not a problem, also the getters and setters. But how easily can you remove a property? Can you use the IDE to do that? Simply pointing into a property and say, delete this, and then remove all the references and for all the methods, everything? No, it doesn't. You have to do it by hand. So wouldn't it be better if we could push down these conventions that we know by heart and push them down to the compiler and let the compiler generate all the boilerplate code? If you are with me in this page, then you will like the project Lombok. Because what Lombok does is hook into the compiler process, give some hints to the compiler using annotations, so that the compiler will generate additional bytecode that matches the expectation. There are some annotations that create bytecode that is not related to the current class being compiled, so that will be a new class. But there are also annotations like the ones I'm showing here that will modify the current bytecode being compiled. So here we're actually looking at two different libraries. One is Lombok for reducing the code that we have to write. And the second one is Jackson for doing the mapping within Java and JSON. The data annotation that you see at the top of the class definition, this is very important. This one says, I'm going to write a getter and a setter for every property that I find. In this case, a private fields, we have 4, so there will be 4 getters and 4 setters. It will generate a constructor. It will generate equals and hash code that uses these 4 properties. It will generate a toString method following a default mechanism that also uses these 4 properties, these 4 fields. Now, if you paid attention to the JSON format we saw before, the JSON payload uses a snake case for the properties. It's what we see there in full_name. But in Java, we are used to, and this is just a convention, of course, using camel case. So full score, capital N, and then aim. So we need a way to map from JSON to Java and making sure that a name that follows one convention can be found in Java using a different convention. That's why we're using this annotation add setter with a very funky syntax. So what will end up happening when we generate the code, when we compile the code, is that there will be a setter method called setFullName using the Java conventions with an annotation on it that is JSON property, and the content of that JSON property is exactly what we see there, full name with using a snake case. So this is exactly as if we had written the source code for the thing. It's just using annotations. Another thing that we can see is the builder pattern. The builder pattern, I like it so that you can write POJOs in an immutable fashion, but the builders are the ones that can change. These are the mutable ones. So you simply have to have a static method with any name you want, annotated with add builder, pass it all the arguments that you want as the values, and then just internally you use whatever constructor you have access to. In this case, we have the default constructor. But if you have final properties, then those final properties will be actually arguments to the constructor. So Lombok will tell you. Here's another thing that you could do. You can have a POJO hierarchy. So you can have an application event class that has nothing to do with Lombok. And then you have another class that can extend from it, annotated with that data. And if you want, you can tweak or give new hints to add data to generate variations of equals and hash code and to string. You can even apply these two other annotations, equals and hash code and to string, separately from data if you want to. I really enjoy working with Lombok. It definitely reduces the lot of source code that you have to write, but gives you exactly the same behavior in terms of bytecode. It relies on the annotation processing tool, which means that in your IDE, you must configure your IDE to have annotation processing enabled. If you're using NetBeans, this is enabled by default. If you're using IntelliJ, you go into preferences and check one of the ticks in the project properties. And if you're using Eclipse, it's a little bit more elaborate than that, but Lombok provides a plugin that allows you to configure Lombok very easily. Also, you will need to install a Lombok plugin for IntelliJ to see the new methods or the new properties added by the annotations. And as said, Eclipse already comes with its own plugin. Extending Lombok is not for the faint of heart. You definitely need to know about the compiler. You need to know about ASD transformations and ASD trees. And yeah, I definitely don't recommend you to do this unless you know what you're doing, unless you have already done this before or something similar. The good thing is that you don't have to write most annotations because the behavior that you expect, well-behaved POJOs, builders, and immutables, and so many other things are already coming out of the box from Lombok. So you simply have to read the documentation for Lombok, see what annotations you need to apply, and then just go with it. Now, this particular project is a project that polarizes the community. There are people that love it, like myself, and there are people that hate it. There is no middle ground. The reason being is that it modifies the bytecode. And some people see this as very, very harmful because they are very cautious, and that's okay. And people like me, I understand what is going on in the implications of mucking around with the compiler, and it's okay with that. So if you want to use Lombok, perfect. If you think this is crazy, that's also perfect. But I've been using this with my customers here in Switzerland, which, and you guess most of the customers are banks. So if banks are willing to use this interesting and exotic library, it might be good for you as well. At the very least, give it a try. If you don't want it, if you don't like it, then just don't use it. That's okay. Now let's go into the behavior. What is the easiest way for you to figure out what is happening on an application? In my case, is putting printouts all over the place. And we know that doing that is not really that good. We should do something better, for example, logging. And I'm going to say, out of all the different logging frameworks that you can find out there, all of them are bad. All of them have problems. But for all the different variations that you can find, only two are a little bit better than the rest. One of them is SLF4J, and the other is the alternative, Log4j2. The advantages of these two frameworks, these two implementations are, well, they give you the same benefits as before as the other ones, like Commons logging from Apache and Java util logging from standard Java, is that if you are consuming multiple dependencies in your application, you're bound to happen to find lots of different login implementations in your dependency graph. So what are you going to do? Would you have to configure every single one of them? No, it would be better if we can configure just one. So what happens with SLF4J and Log4j2 is that every single login call that you find in the other frameworks are funneled into one single API. And that single API is SLF4J. So you can configure all of them in just one place. And the other thing is, when we're making use of a login statement, so for example, you grab hold of a logger and then call info on it, passing a string. If the level info is not enabled, then that string is discarded. Not so bad, I guess. But if you are constructing the string in a dynamic way, you spend cycles constructing the string and doing appending and grabbing the values, whatever is needed, and then because the info was not enabled, the level was not enabled, then what happens with the string? It again gets discarded. What we do in order to avoid this is start adding guards around your statements. For example, we do something like, if level info is enabled, then log info and pass in the information. But this looks ugly. But if we were to use the variable arguments, variations of the login statements, then you pass in a string that looks like a formatting. It actually uses message format. And as many number of arguments than the rest of the method. So the first thing that this method will do internally is check if the particular level that you have requested is enabled. And if it is, it formats the string with all the given arguments and then logs it. So this is much better. This eliminates having if guards all over the place. All right, so now let's get serious with the HTTP. There are many ways out there to query HTTP on Java. There's actually, well, you can start with a URL connection. It's a base class in Java Net package. I believe there is a basic client now coming in, was it in Java 9 or so? But there are very famous open source libraries out there, and perhaps the most common one, the one that most people have seen, is HTTP client from Apache. But I want to show you another one, which is called OKHTTP. The type of behavior that you get is pretty much the same as you have with the other ones. It's just that OKHTTP has 0 dependencies. It's a very tiny library. It was designed to be run on Android devices. So it is very well specialized and has very good quality in terms of the bytecode that it generates. So what we're seeing here is create an instance of an HTTP client, configuring an object of type request, passing it to the client, executing that, and we get a response back. And on the response object, we can query what is the status message, the headers, the content. In this case, we're asking for the body. We're just blindly assuming that we got a 200 request response, and then boom, we go. So this is what I like about HTTP, is it's very tiny. It also understands HTTP2. If you are ready for the future and embrace HTTP2, then OKHTTP is the library I should be using. It's extensible via factors, and we'll see that in just a moment. And the life cycle of HTTP can also be decorated. You can have interceptors that listen to headers being added or removed when a request and a response gets processed. So you can enhance and inject headers if you want to, for example, for basic authentication. There are so many things that you can do here. But let's face it, we are Java developers. We don't want to deal with HTTP because it's very low level. We don't want to deal with status codes and JSON directly and so many different things. So how many ways are there to have REST? There's actually just one way, but there are many different implementations. Should we handle connection errors? It's still very low level. And again, how do we parse our results from one type to the other? So for this, here's another library, which is called Retrofit, also from the makers of OKHTTP. And what Retrofit proposes to you is that you define your REST API in terms of Java code. For example, here in this interface, the first method is the call that we have to issue to grab the repositories from GitHub. You remember this from the earliest slides. So that's a get call, passing orgs, name is a placeholder. And the second method is given an URL parameter. This is if we want to handle pagination. This is something that we haven't seen yet. But trust me, this is how we do things. So notice that it's just a regular Java method called repositories. It takes a regular Java argument string that has an annotation. And the result is some object type call. This is from retrofit, but it gives you already a list, or it could be a collection or a set of repository objects. You remember from the previous slides? Repository is the class that we annotated with Jackson and Lombok. So what we want to do now is create something that understands the contract that we just defined and that also understands HTTP. We're going to use an object of type builder. We pass it some information such as what is the main entry point, in this case the API github.com, that's the URL. We add a factory that will do the conversion within JSON and Jackson. And then we create an object. It does return method, the return call that you see there when we see retrofit.create, that actually creates a Java lang refresh proxy that wraps around an HTTP client and does everything that it needs to do in order to comply with your contract. So after that, you only have to call on the proxy, for example, in this case, the repositories method with a full parameter, which is exactly what we want for Java. So the advantage of a retrofit is that it wraps every REST call using Java interfaces. You can extend it with factories, as we saw with Jackson, and it uses OKHTTP under the covers, which means that any client that you write using retrofit can also benefit from everything that OKHTTP gives you, such as HTTP2 support. All right. Now let's remember that we're writing a multi-threaded application because we have to handle everything that is UI in one thread and everything that is not in any other thread. It could be multiple background threads. It could be many things as long as it's not the UI thread. How do we issue calls on a background? How do we handle multiple threads? So once we have calculated the value or we have obtained a series of results, how do we go back inside a specific thread, in this case, the UI thread? Now see, if some of you have experience with web frameworks, and specifically JavaScript and jQuery, you might have encountered something that solves this. And that something is called promises. A promise is a box that contains a future value. The value will be set at some point in the time, at some point in the future, and you can react to when the value is written or when the value, when the write of the value fails, or you get a timeout, or you get some other conditions. And based on what you get as a result, you could continue chaining and having more promises. Do we have something like promises in Java? Yes, kind of. If you're using Java 8, you have access to completable future, which is but a blocking and non-blocking promise, which is something that I don't really like too much. But if you want to use something that is closer to a jQuery promise, then you should have a look at JDefer. By the way, people are using JDefer on the server side as well with microservices architectures. So let's say that we want to change our contract that we saw earlier, the repositories, and this time we return something called a promise, which is a type from JDefer. And this promise has 3 generic values. The first generic is the type of return, so a collection of repositories. The second type is the type of object that can be returned as an error. We have set trouble, but JDefer is extensible enough so that you can return a string or any other domain object as long as it makes sense to you. And the third one is something also quite useful, is that if the task that is computing the value could have intermediate results and you want to receive notifications when an intermediate result has been computed, then you will this third value and say, what is the type of object? So I guess I could have put the repository, but because I don't care about intermediate results in this case, I just simply say it's void. Okay, so one thing is to say how we define the promise, another thing is to say how we consume the promise. First, we're going to see the producer and then the consumer. Here's our producer. We're using injection. We're using the GitHub API coming from Retrofit. And we have a new type coming from JDefer called Defer Manager. And the usage of this type, you see we're using Lambda expressions, but it could be an anonymous inner class, or it could even be a method reference. It's up to you. Invoking the when method gives us back a promise, which is what's expected. And the body of the promise, or the background task that we're going to execute, is calling the API, grabbing the list of response, checking if the list of repositories are response. If the response is successful, then we return the body. This will be the list of repositories already passed by Jackson. There's nothing that we need to do. If there were to be an exception, then we just simply throw, or a problem, we just simply throw a legal state exception with a message or the response, and that's it. Whatever is coming from the background, from the server. The advantage of this code is it's quite easy to understand in the sense that it just invokes, checks, and returns. And there is no additional confusion on what kind of background information is happening here. The Defer Manager will handle the invocation in a background thread. And you can configure the Defer Manager in many ways as well. So this is the producer. Let's see the consumer. This code will be inside the controller class that we saw earlier. This is a different variation of the code where we can actually have a third value here for the repository. This one does care about intermediate results. Returns a promise, even after we have invoked the repository methods with some arguments. And notice what I have put here in black, 3 method calls: progress, fail, and always. The progress callback, we're using method references, is invoked whenever an intermediate result is available. So what this is going to do is add the repository that has just been computed into a list. If there happens to be an exception or an error, in this case, the second type is trouble, the fail method, the fail callback will be invoked, in this case, just printed to the stack trace. And regardless of success or failure, we will always like to do the following callback, which in this case resets some state, in this case setting the state to ready. Because we see in the first line, we're setting the state to running. So this is kind of like a catch-all. This is kind of like the finally block in a try-catch finally kind of deal. What I like about JDefer is that it definitely gives you the concept of promises much more closer to what you find in other platforms. It's Java 8 friendly. You can use Lambda expressions. You can use Groovy functions. You can use Scala functions. I think you might even want to use Kotlin functions with this. But there is one drawback, if I will say so, is that it only works when you want to compute one value. What if you wanted to have a series of values happening over time? Like in the pagination example, we need to somehow figure out a way to read different pages and give out the results as we process the pages. So this will be like a series of repositories or a series of events over time. Does this sound something familiar to you? You might be thinking of reactive programming, which is kind of like a new paradigm. Basically, what we're doing is register listeners on a particular type, in this case is known as observable, that can trigger events or values as they are produced. There are observables that produce one value and only one. There are observables that may produce or not a value. This is called a maybe, or it's kind of like an optional. And there are observables that can produce many values. These values can be produced without someone listening to them. These are called hot observables. Or these are observables that start producing values as soon as someone is registered for consuming. These are known as called observables. We're basically going into events and streams. So here's an example of the most well-known project that provides reactive programming in Java. It's called RxJava. So what we use is this one that is in red called observable. We expect now our repositories method to return us something that is of type observable repository. And what we're going to do is decorate this observable with a series of operations. The most important one that we see here is a timeout. What happens if the network call takes more than 10 seconds? What we want is this operation to fail with a timeout exception. Otherwise, we could be listening for the network to finish and never have a response back. That would be bad. When we subscribe, this is when the first value comes in. We're going to change the state. When we terminate, regardless of success or failure, we're going to change the state. So again, this is kind of the finally block or the always that we saw in the promise. We subscribe on a background scheduler. This is a scheduler's I/O. And when we subscribe, we pass two callbacks or two functions. The first one is when a new value is produced, when a new event is available, what are we going to do? In this case, add it to a list. And if an error occurs, we're going to print it. Interesting thing about observables is that we can listen to events as they are produced, but the moment the first exception occurs, the observable terminates. And we can have access to that particular exception, but there are no further events that occur. At least that's the default. You can recover from this. Now, there are many operations that you can call on the observable. Is it possible to mix in retrofit and RxJava? Yes, it is. What we need to do is change our contract, the one that we defined before. Remember that the return type was something similar to call of list of repository. In this case, now we have an observable from RxJava of a response from retrofit of list repository, which is the type where we care about. That's basically the only change that we did. The next thing that we need to do is tell our builder that besides the Jackson converter factory, we need to use an RxJava call adapter factory. Again, remember, this is the great thing about retrofit is that can be extended using factories. And this is the only thing that we need to do now. Well, we'll build our proxy, the client that we make use now, will be aware of RxJava. Everything that we need to do. Boom, there we go. Here's a very quick example. This is just plain code that has nothing to do with RxJava, but what we need to do is regenerate an observable of repositories. This is concatenating multiple pages. What I have highlighted here in blue are the different operations that RxJava allows you to use. For every page, we get an observable of list repository. We want to combine all pages into a single observable. And instead of being an observable of list of repository, we want it to be an observable of repository. So this is the reason why we have these two operations, concat with, so that we can keep pushing different observables together, and flat map, which is the one that reduces and removes the list and pushes every repository as a single event over the observable. There are many operations coming out of the box from RxJava, or if you're familiar with Project Reactor from Spring, then they are almost the same API, implemented in a very tiny different way, so you can exchange one for the other. The operations are also very similar. It also supports the concept of back pressure, which is when a client when the producer starts to push a lot of data, a lot of events, and the client is slow, the client will probably die at some point if you cannot process the information fast enough. So what pressure does is give hints to the producer to slow down, or it's a hint to the client, that you can configure this, to buffer the changes so that it can finish processing what it needs to do and then receives the whole buffer of all changes that were stored in memory or some other way so that the client can process them on time. Finally, this is the last library that we have to do in production, then we switch to testing. How do you make sure that two components communicate with one another when these two components don't have a reference to one another? Say you don't use dependency injection within two different controllers because they do not know each other, the instances are created in 2 different points in time, but you still want both of them to be communicated, or it may be some other thing. So what we're going to do here is use an event bus. There are many instances and many variations so that you can use an event bus, but this one, called Ambassador, is very lightweight and is very fast. Here we see in the code the controller, and the only change that I did is instead of printing the stack trace, notice how it handles the error. In this case, it's publishing an event, a throttle event, with the exception that happened, the throttle, publishing in an asynchronous way. What this code is saying is that the producer of the event, which is the controller, will say, hey, here's a throttle event, somebody will handle it, and because it's asynchronous, I can continue to do my own thing. I don't have to wait for all the listeners, if any, to handle the event. There's another variation of the publish method, which is just publish. This is the synchronous way, and this forces the producer to wait for all listeners to handle the event. Sometimes you would like to have this. So this is publication. How we did the consume? Here it is. You can have any class with any name, any type you want. Make sure that you register yourself with the event bus, the same instance, hence why we use dependency injection. Here we have our friends, the post construct and pre-destroy annotations, so that we can be good citizens and register ourselves and unregister whenever this instance is no longer needed. And the next thing we have to do is notice this method that has an annotation called add handler. The name of the method is not important. It could be anything you want. What is important is the type of argument that it has. With that annotation of that type, this will be identified as a listener of throttle events. So in that particular method is what you will put in order to handle the event. This is an event bus that is configurable using annotations. It's much faster than Guava's event bus because Guava also has an event bus. There's actually a benchmark that shows you how good this one is versus the other. Sadly, the author of this library is not so much active these days. So if you ever encounter a problem and you want a quick fix, you will have to wait. But on the flip side, I've been using this library in production for more than 5 years, and trust me, it's really, really good. So you definitely want to give it a try.
Andres?
Yes?
I want to go back to Lombok. So
let's go to Lombok.
So,
okay.
Just a quick question. So how does it work internally? It uses annotation processing to generate the bytecode, or does something else?
It uses annotation processing. There is a JSR, which I cannot recall what is the number. It might be 279 or 297, which defines how the compiler can discover annotations and work with them. So what this thing does is when the compiler encounters the annotation, in this case, add data, it will trigger some other type, some other class that exists in its processor class path. And this processor is the one in charge to figure out, okay, so I'm going to read the descriptor of the class and maybe look at all the in this case, the fields, and if they follow certain conventions, so they have to be private, then it will generate whatever code is appropriate.
Andres, another question. Can you hear me?
Yes.
Actually, we just started using Lombok in one of our projects to generate getters and setters for the POJOs. There's actually a lot of them, and it will help us first to reduce the code, and second to worry less about code coverage, because our code then has to be covered in unit tests. So yes. It will help us also on that. But are you aware of any performance concerns for Lombok? Will it? I don't know. Are there any drawbacks or?
Okay, so that's the very two good questions. First one, I have to say that since latest versions of Lombok and Jacoco, if you use Jacoco for code coverage, which I highly recommend, since Jacoco 0.80 and Lombok, I think, is 1.18.0, there is an annotation in Lombok called @generated. which is added to all the fields, properties, methods, constructors that Lombok adds. When Jacoco sees this annotation, it will skip calculating code coverage. Okay. So it doesn't affect your numbers. If you see getters and setters that you have to test somehow, in this case, it's completely transparent, and Jacoco will only cover the code that you write. Second thing that I should mention is that if you write a setter and you still have a method like a field like this with add data or add setter, if Lombok sees the method that it should have been generated and it's available in the source, it will leave it untouched. So if you want to still manually change some things, you can do it. So you can have a hybrid of manual code and Lombok. And finally, in terms of performance, Lombok does not work at runtime. It's only at compile time. So is the bytecode generated from Lombok good enough? It actually is. It follows, most of the annotations, the implementations that you see in Lombok follow the guidelines that are found in Josh Bloch's Effective Java book series. But if you still have doubts, and that's okay, there is another additional project to Lombok called dlombok, which generates the source code of the matching bytecode. And this you can use to do debugging. Because if I were to put a breakpoint in say, the name field, and for some reason I wanted to stop in the getter or the setter, while running, you can. But there's no way I can put the breakpoint here in my source code. But if I do run dlombok, I associate that source, the generated source, with my debugger, and I can see everything. Worst case scenario, you can use Lombok as a source code generator. First, you compile the class, then dlombok, obtain the source, and then put it back into your code base, and there you go. But this is quite contrived, and definitely, you will probably use this in very rare cases. Just know that it's something that can be done.
Okay, thanks a lot.
Thanks. All right, any other question? All right, so let's move into testing. I promise this will be quick. Before we do that, does anybody in the audience ever run parameterized annotations by JUnit 4?
Yes, I did.
Okay. Did you like the experience?
How did I like the experience? I did it once. It was not easy to do it. No.
It was not easy to do. It's quite contrived. You had to put a state on the unit test. So you had to define fields that contain the values. And you can only parameterize the same. If you have more than one method that you want to parameterize, they have to receive the same arguments in the same order, same cardinality. If you want to have two different use cases in the same test case that have different parameterization, then you simply can't do this. But if you use JUnit params in combinations with JUnit 4, then you can have this. And there are many ways. There is one way when you can define the arguments directly and the annotation, in this case, the parameters annotation. You can define the name of a method, or you can define the name of a class that gives you the behavior. If you were to use JUnit 5, the parameterization provided by JUnit 5 is even better. Notice that if you're using JUnit params, you need a custom runner. So if your test case is already using a runner, you won't be able to use JUnit params. It's either one or the other. Next one, mocking. And I think most of you might be familiar with Mockito.
Yeah.
What I have highlighted in blue is what we do. What we want to do is have a unit test where the collaborators are fake, are lightweight, because we only want to check or test the class under test. In this case, we have the class under test is a controller. We pass a simple model, which is just a regular project with getters and setters, so we don't need to fake this. But the service type is actually something that we want to fake, so we mock it using a static method from Mockito, which is called mark. Then we define our expectations using the when block. So here what we're saying is that we grab a reference to the mock, because this is controller get service. We invoke the method like, or appears like we invoke in the method, say hello with certain input. Notice that we're using parameterization. And if this expectation is matched, then we return certain output, which is also coming from parameterization. Then we execute the stimuli, we execute the controller, we verify that it did the right thing, but also verify that the mock was invoked once and that it returned, and that actually was invoked with a given input. If the service, the mock service was invoked more than once or none times at all, there will be a failure. If the say hello was not invoked or was invoked with a different type, with a different argument, that also will result in a failure. So the advantage of Mockito is that it has a fluid DSL for defining our expectations using static methods. You have support for stubs, which are fake objects that return a value. That's it. You have mocks, which are stricter. This one validates how many times you call them, with which arguments, and in which order. And finally, you have spies, which are real objects for which you just want to mock out or fake out certain replies. You will encounter in some cases when, say, let's say you have a real response object, but you only want to fake out the status code, and there is no setter that you can see from the outside. You only fake out the get status code in this case. But the rest of the behavior of the response object, you want the production behavior. So you use an spy for this. With Mockito, you can mock out interfaces, you can mock out abstract classes, concrete classes, and even final classes. If you're using JUnit and Juice and Mockito, then there's another project called Jukito, which combines the three of them put together. You have to use a custom runner, so that might be a little bit of warning there. You can inject values or instances into your test case, as we see right there in the third row. I put in blue exactly the same code that we saw in the plain Mockito class. The set of mocks receives an argument, which is the type service, for which we did not provide a binding. So the advantage of Jukito is that it says, if there is no binding coming in a juice module, which is how you define the bindings, then I'm going to create one on the fly. I'm going to use a mock and going to supply it to you. So if there is one component that requires this interface, this type, then it's going to be injected. It's going to inject the mock. If there are more components that require this, they're also going to inject the same mock. So that's great. So then we use the expectations just as we did before without parameterization in this case. We execute the test method, and we see that the verification phase is exactly the same, also without any parameterization. So that's quite the advantage of using the three together. There's even a way for you to parameterize methods using Jukito. It requires some annotations that you add in this case, it will be the method annotated with @before. Or I heard that some of you like Groovy, and if you feel adventurous to try out a different language, then give Spock a try. This is exactly the same behavior in the other test cases, but the code, of course, is Groovy, and it starts to look a little bit interesting. Say, what about that method name? Is that something that strikes you as odd there? It is a string. And it has some things that look like placeholders that they use in the hashes. The first thing you know is that any character is a valid character. Any character that you find in the JVM is as a valid character to be used as an identifier. You can put spaces, you can put anything as long as it's UF8. Java, the language, is the one that restricts the number of characters or the character set that you can use. But Groovy and Spock gives you back these capabilities. So you can put spaces, as you can see here. Given that Groovy supports multi-strings, multi-line strings, you can put a whole paragraph right there that is very, very descriptive of what you want to do. Then we see for blocks. given when, then, and where. These blocks are special in Spark. The given block is where we set up our expectations, is where we set up our collaborators. The when block is where we execute the actual stimuli. The then block is when we do the assertions. And are we missing something there? I said assertion, so where's the assert that, assert equals, or even the assert keyword? Well, guess what? Given that we know for a fact this is the assertions block, assertions are implicit. You don't have to put them, but if you want, you can use them. And finally, the where block is where we do parameterization. There are many ways to do parameterization, and what this interesting syntax is saying is that there will be a variable called input, whose values will be coming from a list. We have list literal syntax for collections in Groovy. And the shift operator that you see there is in telling Spark that for every row in the list, in this case there are only 2 rows, there will be a value added to input, or in this case output. Now the placeholders that you see at the top in the method name should have the actual values for every iteration. In order to see that in the report, in the HTML report, and even in the IDE report, we annotate the class with another annotation called onRoll. So when I run this test case and I get the report, I will see something like inbox say hello with empty string results in test. And another one saying inbox say hello with howdy stranger results in hello test. Those will be the actual method names. There's also a way to do, you can see in the middle, how to do mocking. Spark has its own mocking library. It's its own way to do mocking. Actually, the author of Mockito and the author of Spark used to work in the same company. So Spark got a lot of inspiration from Mockito, and they use the same underlying libraries to enhance the bytecode. So I really like Spark. It gives you many advantages over the other testing libraries. It's still ways ahead from JUnit 5 in terms of parameterization. And it's very JUnit friendly. It's JUnit 5 and even JUnit 4 friendly. So every extension and every JUnit 4 extension and JUnit 5 extension, you can still combine it with a Spark. Here's another one. We know for a fact that our application uses multi-thread. I should already give you the answer. How do we test out multi-threading code? If we know that something is running in a background thread, we need somehow wait for it. Now, the typical reaction will be to put thread.sleep in our test case, isn't it? And give it a timeout. How big of a timeout should it be? Is 100 milliseconds enough? 500? 1,000? 5,000? It doesn't matter. The number that we put in the thread sleep is the exact number that the test case is going to wait, whether it's too much or too little. It would be much, much better if we had a conditional way to wait for something to occur so that we can continue. And that's exactly what our utility is doing for us. In this case, again, this is a regular Java class. And we use the await method. It's a static method coming from our utility. And we say something like, we're going to wait at most 2 seconds. This is our timeout. In the following condition, we'll see what is not fulfilled within those 2 seconds, then we're going to fail. The condition that we're stating is comprised of 2 things. One, the object and the value that we want to extract. In this case, we're using a method reference, grabbing the state value from a model object. And the second one is a handcrest matcher. Handcrest comes baked in from JUnit. So in this case, we're saying if the condition is the state is equal to ready, and that happens before 2 seconds, then the next block is going to be executed. But if it's not, we're going to fail. So this ensures that our test case will wait at most 2 seconds. But if the condition is resolved in less than that, say 200 milliseconds, great. At some point, it may be a little bit slower. At some point, it might be a little bit faster. But you are not limiting yourself to a fixed timeout. And that's the advantage of our utility. You can combine it with Java 8. You can use method reference and lambdas. You can combine it with Groovy and Scala. I'm pretty sure you can also combine it with Kotlin. And you can customize it with any kind of handcrest matcher. You can even provide your own custom handcrest matchers. Now, the last one that I'm going to show is a little bit have to do with integration testing and functional testing. We know we're talking to the GitHub API. So how do we test out the GitHub API? How do we test our controller of a service? Should we ping the actual GitHub server? What if we don't have network? What if we run out our limit rate? That's not good. So should we fake out the GitHub server? That is too much, faking out the API. Say that you find a way to fake this out. When do you run it? Do you run it as a server outside of your test cases? Do you run it as part of the build process? Or do you run it as close as possible within the test case? So my suggestion is to run it as close as possible to the tests. So the project that I want to showcase is called WireMock. And what WireMock allows you to do is create a fake server in test next to your test case. And what you do is you want to fake out request and response. What we're doing in this particular DSL is creating a stuff for an URL that looks like orgs and the organization and repos. So this matches the URL that we saw in the beginning. And it has to be a method type, an HTTP method type get. If there is a match, it will return with 200. It will say the content type to be JSON. And we're going to use Jackson to serialize a series of objects. If we get another URL, another match with those particular conditions, then it's another 200. It's another content type, text JSON again, and another list of repositories. With WireMock, you can also return any type of response. You can delay the response if you want to. You can match anything you want to. Now, the thing is that when I run this test case, and if there is no match for the get call, then the test case will fail because we set an expectation and it was not fulfilled. Or if you have more than one match, then it will also fail because in this case, we're expecting just one particular call for this one, just one invocation. If there were to be two or more, then that would also be a failure. WireMock runs using JUnit 4 rules. I'm not aware if there is already a JUnit 5 compatible extension, but expect this to be done pretty soon if it's not already done. You can define expectations programmatically as I showed, or you can also use WireMock in record and playback mode. So you can run your server in the background and start hitting it with a client. The server will record every single request that you make, and then you can use them to replay everything you want to. You can even hook in any type of response. So this is pretty much it. I guess this is a nice list of libraries that you can use in many different types of applications and projects. But what about X? What about the other libraries? Every time that I make this presentation, there's always someone that says, oh, but you forgot about this particular library. Yeah, I'm aware that there are a few other popular libraries out there. For example, I could be talking about Hibernate. How can I talk about JPA without mentioning Hibernate? Or what about doing remote procedure calls? So yes, I will definitely talk about gRPC. There are so many different things, but we don't have enough time. But you will find in the link of the repository that I posted earlier, a few other applications that make use of different libraries as well. In there are 4 different variations of an RPC or a chat, and there are other variations for web and a few other things. So this is just the tip of the iceberg. But I will hope that I give you some hints on certain particular libraries that you can use in your daily work. Everything that we saw, again, a reminder, is open source. You too can contribute to open source very easily. If you find a problem with any of these libraries or any other open source dependency that you're consuming, please file a ticket. Just let the people at the other side know that you encountered the problem. Give a short description of what is the problem, steps to reproduce. If you can supply information about environment or even a test case, that's great. But if you don't have the time to propose a patch, that's okay. No problem. But at the very least, file the ticket. If you have the time, the passion, the inclination to supply a patch and continue engaging with the conversation, then please do. This is the way that everybody wins. And I can assure you by my personal experience that once you have gotten into open source, your own personal skills as a developer will be better. Your soft skills for talking to people will become better. I have to confess that I got into this industry, I got into doing software because I didn't want to talk to people. Yet, here I am talking to you over the network, because this is what happens with open source. You really want to share knowledge. So these topics that I discussed today, I cover in a newsletter. The first link is in English. The second link is in Spanish. It's actually the same content. And if you want to follow them and you want to be notified, then I will appreciate it. If you have any comments or any doubts, also, please do let me know. And with this, I think this is all that I have for you today. I thank you very much for your time. I hope that you have enjoyed today's presentation. I will encourage you to continue coming to these presentations, to the presentations organized by Duke Beirut. And next time you can convince a friend to come in along with you. So thank you very much.